So on this worksheet of notes, I gave you a handy-dandy table from the book with the different areas or different formulas you might need to use for some of these next few examples. The first one, I mistyped apparently. Find what is the radius of a circle whose radius is 64 feet? Well, obviously it would be 64 feet, right? How about, let's do circumference. Whose circumference is 64 feet. So we're going to look for the circumference of a circle formula, which is right there. So we plug circumference in for C. So this is what we're using. Remember, pi is a constant. It's not a variable. So the circumference of 64 feet is equal to 2 pi times the radius. And a lot of times with these formulas, instead of solving for the radius first, might help just to plug in the formula and solve. So we're going to divide both sides by 2 pi. And we are going to that noise was me getting a calculator. And so 64 divided by 2 pi. And on a lot of your calculators, you have an actual pi button that you can use. Please use that. It makes the answer a little bit more precise than just using 3.14. So using that actual pi button, we find that the radius is approximately 10.19 feet. So that is the radius of that circle. All right, so we want to find the height of a triangle in number 3, the height of a triangle whose area is 24 square inches and whose base is 8 inches. So we're going to use this formula. If you look back at the previous table, the area of a triangle is 1/2 the base times the height. And we're going to plug in what we know. We know the area is 24. We have the 1/2. We know the base is 8 inches. And we want to find the height. So we are going to solve for the height. The first thing we can do is multiply the 1/2 and the 8. And the 1/2 times the 8 is 4. And then to solve for the height, we divide by 4. So then the height is 6 inches. That's the height of that triangle. Now in the next couple, I believe we're going to use the distance formula. And the distance formula is distance equals rate times time. Again, from that table. So the monarch butterfly is the only butterfly that migrates annually north and south. The distance that a particular group of monarch butterflies travels is about 1,700 miles. It takes a typical butterfly 120 days to migrate this distance. Approximately how many miles does the butterfly travel per day, basically? So what do we know? We know the distance is 1,700. We don't know the rate, but we do know the amount of time it takes. It's 120 days. So we are going to divide by what's being multiplied to the r, 120. So then r is approximately equal to, because I don't believe that comes out evenly. When I take 1,700 and divide it by 120, so it's approximately 14.17 miles per day. Don't forget to label with the proper units. This is another distance problem, so distance equals rate times time. And the Pacific gray whales migrate annually. The whales travel a distance of 5,000 miles, so there's our distance, 5,000. Plug that in for D, at an average rate of 91 miles per day. So there's our rate. We want to know how many days or how much time it will take. So then we divide both sides by 91. So it will approximately take about 55 days to make that migration. And keep this example sheet handy because it will be very useful in some of those formula problems on the practice in class.